In this video, we're talking about the Go method, which is the main method that you want to write in your artificial intelligence. It's going to be the one that you use to attack your opponent's game board. And remember, just like the hide ships method, the Go method has to work without interaction from the user. So it won't be the case that you'll print something to the screen and say, like, which square do you want to attack next? And they'll type in a row and column, and then your Go method just has to carry that out. Instead, your Go method has to contain all of the logic to select a square on the game board to attack, and then think about, like, what square should I attack next? So because you're going to have to save information about the row and column that you want to attack in between calls to this method, you're going to need to add some instance variables or data fields to your class. Remember, those go up at the top of your program, and those are globally accessible to all of your methods. So they'll allow you to save a state about your current game board and how you're attacking your opponent in between your turns in the game. So we want to be able to store information about the row and column that we want to attack. So I'm going to create two instance variables, a row, which I'm going to initialize to 0, and a column, which I'm going to initialize to 0. And then I can use those two values inside my Go method to attack that square. So remember that your Go method, when it gets called, it's supposed to call fire at on the board object, which is passed in by a parameter. So it's passing in your opponent's board, and you use that to call fire at. And you can only call fire at one time, otherwise it's going to flag you as cheating. Because just like the regular game board version of Battleship, if you're trying to, like, fire at 2 squares at the same time or something like that, your opponent's going to call you out as having taken 2 turns instead of just 1 turn. So each time that the Battleship tester calls your Go method, you have to fire at just 1 square. So the fire at method, remember, that's part of the board class. We'll switch over and look at that for a second. So the fire at method, it takes a row and column as the parameters, and then it checks to make sure you're not cheating, you haven't already fired at a square this round. Then it fires at that particular square and keeps track of the fact that you've already fired at that square, and then it returns the contents of that square. So that's what comes back from the fire at method. So I'm going to write the least intelligent gameplay possible. You should strive to do something above and beyond this as satisfying the minimum requirements for this project. But just making a valid call to fire at would involve using my opponent's board, and I want to call fire at, spelled it wrong, fire at, and I have to pass in 2 parameters, the row and column that I want to fire at. So I'm using those 2 instance variables that I just created up at the top of the program. So I'm firing at square 0, 0. And my Go method's not supposed to return anything. It's a void method. So I've satisfied all the requirements here. I called fire at, I only did it 1 time, and I indicated the row and column where I wanted to attack my opponent. So let me go ahead and run this particular program. Actually, before I run it, I'm going to go in and edit my Battleship tester. I'm going to do that so that instead of playing multiple games, it's just going to play 1 game. So I'm going to comment out my for loop. So it just plays 1 game. And if you want to, you can also change how many times, how many turns you get in the game. Like, suppose you're like, I don't need to fire at 100 spaces. My algorithm, I'm just trying to test it out. I'm going to change this so I only get 5 turns. It'll just make it so it prints less output. Or you could try just like 2 turns to get less output and not visually overwhelm yourself with the output of the program. So again, what I did in the Battleship tester file was I commented out the for loop that repeats for 3 games, and then I also changed it so that rather than having each player take 100 turns, which is like the maximum number you should have to take before somebody wins the game, because there's only 100 squares on your game board, I'm changing it so that it only takes 2 turns in the game, because my algorithm, you already saw, it's not that intelligent. It's not going to do something different at each iteration. All right, so now I'm going to run my program, see what I get. So I got lots of output down here. Try to drag this so we can see more output on the screen. So remember, this first step is showing me the game board setup. This is for player A, and then this is for player B. And my code always prints the same board for both of those, which is completely fine when you're writing your own project. And now step number 1, you can see that when it prints the output, it's putting this little square here. That means that's the square that I fired at, and that particular square was a miss. And then my program uses the same algorithm for both players, and that's what your program's probably going to do too. So player B then takes their turn and does exactly the same attack square 0, 0, prints the same kind of board update. And then my program, remember, it's always attacking square 0, 0. So on turn number 2, I attack that same square. So I get a miss again, and then player B attacks that same square and gets a miss again. So my program's working. Again, I have the least intelligent AI algorithm in my Go method. Things that you could do, you could save information about the character that comes back from this. So you could store the character. If you wanted to, you could print it out just so that you could see what it was while you're kind of debugging. But in your program, you wouldn't want to print something out and then have the user have to respond to that, because that's not allowed in the gameplay. But you might want to do something with the information that comes back from the opponent's or the fire at method, so that you could do something intelligent in your algorithm to maybe guess where to look next in your player's board. In general, you'd also want to do something that allowed you to update the value of row and column so that you're not always firing at the same square. So think about that. Like, suppose that you wanted to, rather than always firing at square 0, 0, you wanted to advance to the next square in the game board. So after you fire at 0, 0, next you want to fire at 0, 1, and then you want to keep moving across, and next you're going to fire at 0, 2, and then 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. And then after you get to the end of the row, you'll need something that allows you to reset the column value to be 0 and advance the row value. So it's kind of the minimum possible requirements that meet the spirit of the Project 4 assignment and allow you to guarantee yourself at least that 85% or better in your grade for the project. And again, there's not a lot of code involved in doing that. You just need to set something up so that you advance the value of row and or the value of column each time you take a turn in the Go method. And you do that just by changing the value that's in here. Like, suppose that after square 0, 0, I want to fire at row 5, column 5. Let's run the program with that. Now you can see in my solution that first time through, I'm firing at square 0, 0, and my game board gets updated. And then the next time through, I already fired at 0, 0, and my new square that I'm guessing is square 5, 5, right in the middle of the game board. So it's showing that as a hit for the destroyer. So again, just changing the value of row and column, you just do that by updating them inside the Go method. I wouldn't just update them so they're always 5s, because that doesn't make sense. Then like the third turn, you're just going to hit 5, 5 again, and the fourth turn, you're just going to hit 5, 5 again, and so on. That's not going to help you win. But if you're constantly changing the value of row and column by incrementing them, then you'll be able to cover the entire game board.